Okay, on composite functions, got 4 examples. For the 4 examples, we're going to use functions for f, g, and h. Now, composite functions you may have done before, but you might not have recognized this form. So there's this little circle right here. So this circle is g composite h. So composite functions, the little circle. All right, here's how you set them up. You've got g composite h. Whatever letter is first, the g is first, write that function down. So g is 3x plus 7. So we write down 3x plus 7. G's first, write it down. Next, anywhere that you have an x, we're going to open that up and we're going to make a substitution. What you plug in there is what letter is next. H is next, x minus 2. That's what we're going to drop in there right now. X minus 2. So g's first, write down the g function, open up to sub in, plug in whatever letter's second. H is x minus 2, that's what we drop in. Now we got a little bit of math to do. We're going to distribute 3x minus 6 plus 7. And when you have 3x minus 6 plus 7, looks like you get 3x plus 1, final answer. All right, so for all of our examples today, there's only 4. We're going to use this, f, g, and h for composite functions. All right, get them written down. I need this space. Here we go. Let's do a second one. Let's go f composite h. So another composite function, f composite h. Your first letter is f, so you just write down the f function, which is x squared plus 5. Anywhere you have an x, you're going to open that up and you're going to make a substitution. So what we're plugging in is the second letter, h. H is x minus 2. So x minus 2 is what we're dropping in. Now when you go to do math, you see this is squared. Make sure you think about squared. There's 2 of these. There's one x minus 2, and then there's a second x minus 2. So when you multiply this all out, make sure you've got it written twice. This will be x squared minus 2x plus 4. So, like terms in the middle, x squared minus 4x plus 4 plus 5. And then one more step to clean up. X squared minus 4x plus 4 plus 5 is we're just going to clean up the 4 plus 5, make that a 9. Okay, f composite h, f was first, plugged in the h, did a little bit of algebra. All right, 4 examples. There's 2 of them on the composite functions. Let's throw a little wrinkle in with you. Let's put some numbers in there for this third one. What do we got for number 3? H composite g. So here's h composite g. But this time, they're going to give you a number that we're going to substitute at the end of the problem. So hold on that 6. Let's do h composite g first. We'll just run it. H is the first letter. My h function, x minus 2. So whatever letter's first, you just write it down. H is first, x minus 2. Write it down. Anywhere you have an x, we're just going to open it up and make a substitution. Plugging in x minus 2. Now what's next is g. So g is what drops in here. My g function is 3x plus 7. All right, so I've got g plugged in. Let's clean it up. And you got your first answer, 3x plus 5. Now we're going to deal with this 6. What you need to do is just grab the 6, plug him in place of your x. Let's do a little cleanup. See what's left for our second answer. So what do we get here? 18 plus 5, 23. So you get your first answer, h composite g. You get your second answer, the 23, when you plug back in. All right, these have all been nice, neat. let's drop in a fraction and make your life difficult. All right, one more. Let's make this one a little bit more rough. Number 4. Let's go F composite G. And let's put a negative 1/3 that we're going to drop in there. All right, save that fraction for the end. Let's go right now. Let's do the composite function, F composite G. So F is first. You write down your F function, which is just x squared plus 5. F is first. You write x squared plus 5. Now, anywhere that you have the x, you're going to open up and make a substitution. What you plug in is your second letter, G. G is what plugs in there. So G is going to be 3x plus 7. Now this 3x plus 7 is squared, which means there's 2 of these. So you've got to write 3x plus 7 once, 3x plus 7 twice. So we've got to multiply all this out. Make sure you've got it twice. 3x times 3x, 9x squared. So let's hit both of these. Plus 21x. The 7 hits both of these. Plus 21x plus 49. So we're going to multiply this out. 3 times 3, 9x squared. The 3x times the 7. The 7 times the 3. The 7 times the 7. Looks like I get one more step on here. I can get 9x squared plus 42x. And then I got to add 49 and 5 together, which looks like it'd be about 54. I think you can see that. So there's your first answer. Ha ha ha. Now we got to run a second answer on this. I wonder if I can fit that up there. Won't even try. Let's just put it real big. 9x squared plus 42x plus 54. All right, second answer, we're going to grab that negative 1/3. And we got to drop it in place of x. So we have a negative 1/3 that we have to plug in place of the x. And now we got some crazy math to do. Let's do this first one. A negative number that's squared. Negative squared. Turns out to be positive. The squared hits both of these. So 1 squared is 1. 3 squared is 9. Whoops, that's not going to be positive for long. Now this is kind of nice right here. You got the 9 and the 1/9. 9s cancel out. That's just going to be 1. The negative hits the positive, so that's negative. And then you got 42 divided by 3. 42 divided by 3, that's just 14. Drop down to 54. All right, now we're close. We just got 1 minus 14 plus 54. Looks like a total of 41. So, composite functions. And a little kicker, sometimes you got to plug in numbers or a fraction.